Hi everyone, so in this video we are going to solve our assignment 13. So I have already shown you the questions. I hope you must have attempted all the questions and now we are going to solve it. It is a very basic assignment. So this is the first question which is very easy. So what we are going to do, we need to find the value of V naught. So what will be your V naught? V naught will simply be 1 plus RF by R, RF by R. What is RF? RF is 9 kilo. 9 kilo by R. What is R? R is 1 kilo. Into the potential, this potential into V negative, V positive potential. What is the potential of V positive? Let us consider that is V. Let's consider that is Vx, not V, it is Vx. So your V naught will be tan Vx. This will be your V naught. Now your target is to find Vx potential. So what will be your Vx potential? So for Vx potential, I have already shown you this. Since here there is 0 ampere current, so I can apply that formula. Which formula? V1 into 3, V1 into 3 plus V2 into 2 divided by 3 plus 2, 5. And if you are not applying the formula, there is no need to worry, you can apply nodal as well. Vx minus V1 by 2 kilo ohm plus Vx minus V2 by 3 kilo ohm is equals to 0. From there only we get this formula, but this formula is again and again used, so we typically remember it. So V naught is equals to tan into 3V1 plus 2V2, 3V1 plus 2V2, 3V1 plus 2V2 by 5, and that would be equals to 6V1 plus 4V2, right? So alpha value is 6 and beta value is 4. So what is alpha plus beta? That is 10. That's it. So these kind of questions are very basic, very easy. Within 1 minute you will be able to answer it in the examination. In the examination you will see what is the Vx potential, 3 into V1 plus 2 into V2 by 5 into 1 plus RF by R. That means into 10. That will be your final answer. That's it. This step only you will write. That's it. Let's move towards the next question. We have to find R in value. R in value from here. So what you will do? You will apply a voltage source and get I in out of it. So what will be your R in? Your R in is, your target is to find V in by I in. That's it. This is your target. So how will you fulfill your target? So this is the I in current. So this I in current cannot go here, right? This I in current cannot go here. Why it cannot go here? Because input current will be 0 ampere. This is the ideal op amp. Input current of ideal op amp is 0. This I in will go here for sure. This I in will go here for sure. But this I in cannot go here. Why so? Because output of op amp can drive some current. It can drive some current. It's not that I in will be flowing like this. So I in need not necessary to be this. Okay, because op amp, output of op amp can drive some current. Input of op amp will have 0 ampere current, but output of op amp can drive some current. So what we will do? If this node is V in, certainly this node is also V in. Then certainly this node will also be V in. So what you can do? You can write the potential of this point, right? If this node is V in, this node is V in, then you can certainly see what will be your V naught. You can apply nodal here as well. V in by 10 plus V in minus V naught by 100k is equals to 0. You will get the value of V naught. Otherwise, what is the other method? The other method is 1 plus RF by R, because it is becoming non-inverting amplifier. It is acting as non-inverting amplifier only. 1 plus RF by R. 1 plus RF by R into V in. So your V naught is becoming 11 V in. 11 V in. So now you can, so this potential, this node is 11 V in. So this node is also 11 V in. So what do you see here? V in minus 11 V in divided by 1 mega ohm is equals to I in, right? So what will be your R in? Your R in is V in by I in, 1 mega ohm divided by minus 10. 1 mega ohm divided by minus 10. Mega is 10 to the power 6 divided by minus 10. What it would be? 10 to the power 5 minus 10 to the power 5. Or you can say 100 kilo ohm. 100 kilo ohm. So V in by I in is 100 kilo ohm minus of 100 kilo ohm. So your R in is becoming minus 100 kilo ohm. So your answer is minus 100. Understood? Very easy question. You just needed to find V in by I in. Then you got to know that you don't know this V naught potential. Also, you cannot keep this current like this, because output of op amp can drive some current. So if output of op-amp can drive some current, so you have to find this potential V naught. So if this node is V in, then certainly V naught will be 11 V in. The 11 V in will be coming here. V in minus 11 V in divided by 1 mega ohm is equals to I in. So V in by I in is minus 100 kilo ohm. That's it. That's your answer. Let's move toward the next question. You have to find the expression of I naught, but it is such that I naught is such that it is not a function of ZL. This is a load impedance. So your I naught, the current that is flowing into the ZL, that is not a function of ZL. The current that is flowing into the load, that is not a function of the load. So what we will do? So this node is 0. Actually, when I showed you the question in the previous video, I did not show this ground. I should have shown this ground. I am really sorry for that. So this is ground here. Okay. So this node is 0. So this node is V in. Right. If this node is V in, and can you tell what will be this node? No, you cannot tell. Don't say this node will be minus V in. Don't say that like that. It would have been minus V in only when this node was at 0. This node is not at 0 now. It would have acted as non-inverting amplifier. The formula that we remember, minus RF by R into V in. That would be if this positive terminal was at 0. But this positive terminal is not at 0 now. Right? Ground is here, not here. So you can't say this will be minus V in. Many students can do this mistake, but I hope you didn't do this mistake. So let's just assume this potential is potential V or V2 we can say. If this potential is V2, then this potential will also be V2. If this potential is V2, then this potential will be V2 by 2. So yes or no? This is V2, then there is a negative feedback involved. So this V2 will be carried here. Now this V2 will be coming here as well. Simple voltage follower it is. V2 to V2. If this is V2, this will be V2 by 2. Now this will be V2 by 2. So this will also be V2 by 2. Right? And this will be copied here as well. V2 by 2. Let's just assume this node is V1. So let's find the value of V1 in terms of V2 and V in. Can we do that? Yeah, we can certainly do that. Here I can directly see that V in plus V1 by 2 is equals to V2 by 2. How did I write that? This node is V1. This node is V in. V in into RA plus V1 into RA divided by 2 RA is equals to V2 by 2. Say yes or no. V in into RA plus V1 into RA divided by RA plus RA, that would be 2 RA, would be equals to V2 by 2. So 2 and 2 got cancelled, RA and RA got cancelled. So V in plus V1 is equals to V2 only. This is what I did. So although if all those things doesn't click to you, इतना जल्दी नहीं समझ में आता है, so you can simply apply nodal analysis and you will get the final answer. But to make the calculation faster, these kind of short tricks if you use in the examination, your calculation will be faster. That's it, nothing else. So you can apply nodal analysis as well. There is no issue. So your V1 would be V2 minus V in. So this node is V2 minus V in. Now this node is I naught. This current is I naught. The same current will be flowing through R as well. Why is it so? Because this will drive 0 ampere current. Input of op amp will drive 0 ampere current. So the same current I naught will be flowing through R as well. Right? So this node is V2. This node is V1. So what is your I naught? I naught is V1 minus V2 divided by this resistance R. What is the value of V1 minus V2? V1 minus V2. What is the value of V1 minus V2? V1 minus V2 is minus I1. V1 minus V2 is minus VI. V1 minus V2 is minus VI. V2 minus VI minus V2. It would be minus VI. So minus VI by R. So this is your I naught. That's it. So your I naught is minus VI by R. There you got to know that the load current is not depending on the load resistance. So this is also acting as a voltage to current converter. This input voltage is converted into the current, voltage to current converter, right? Let's move towards the next question. So this question, and then there is one more question. The same kind of question are there. These questions are interesting, very interesting. Okay. Now, if you see this particular problem, you have seen the half wave rectifier using diode. You have seen full wave rectifier using diode. Not using diode, using op amp as well. Full wave rectifier using active element, that is op amp, and half wave rectifier using op amp as well. So there what we used to do, we used to check V in. If V in is negative, that means if this is negative, then your output will be plus V set, right? V in, this is minus 1. Minus 1 is less than 0. What we used to do is that first we used to keep the diode as open circuit. We applied the open circuit test, then we used to see what will be the output. If I apply open circuit test here, this will be open circuited. There is no feedback. There is no feedback, then minus 1 will be coming here. Minus 1 will be coming here, so output will be plus V set. If there is plus V set, that means this diode will turn on. So I would have replaced this diode with the battery. This is what I used to do. Right? Do you remember it? This is what I used to do. But in that case, the current equation was not given. Here the current equation is given. Are you getting this point? Whenever I used to solve those previous problems, at that time the current equation was not given. I used to consider the model as piecewise linear model. This model I used to consider. We have studied diode, we have seen different kind of models. This model we have seen, this model also we have seen, and this is the ideal diode characteristics. This ideal diode characteristics. So now I am going to consider what kind. Now for rest of the time I was considering this model when I was studying half wave rectifier, full wave rectifier. But now the equation is given, so I have to consider this model. Okay, so I cannot replace it with the battery of 0.7. Nothing, no V gamma value is given, no cut-in voltage is given, nothing is given. So I cannot consider like that. Now I have to do the exact analysis that will be considering the equation. So what I will see is that if this node is 0, assuming the diode is on, and certainly it will be considered on only. Okay, assuming the diode is on, this node will be 0 because there will be feedback. Assuming diode is on, so there will be feedback. This is giving me a finite voltage. If this diode can give me a finite voltage, it can be 1 microvolt voltage as well. Any voltage. If the diode is giving me any voltage, then the diode will be on. And then there will be a feedback path. If there is a feedback path, that means virtual short is valid. So assuming the diode is giving me a finite voltage, so the virtual short is valid. If virtual short is valid, what does that mean? Where is the current flowing? What is the direction of current flow? This is the direction of current flow, right? This is the direction of current flow. What is this current? 1 by 100K. Or you can write 10 microampere. Say yes or no. The current is 10 microampere. Now the same 10 microampere current is flowing through this diode as well. Now the current direction is from P to N. So 10 microampere current is flowing here as well. The same 10 microampere current. So what is the value of I? I is 10 microampere. Say yes or no. What did I do? I saw that the current is flowing here is 10 microampere. The same current is flowing through the diode. So value of I is 10 microampere. So now value of I is 10 microampere. Now how much voltage drop this diode will give me? That I will determine with the equation that is given. So what is the equation is given? I is equals to I naught e to the power V upon Vt minus 1. I value is 10 micro. I naught is called as a reverse saturation current which is 1 micro. E to the power V I don't know how much voltage drop it will give me. Divided by Vt. Vt is 25 millivolt. Minus 1. Well and good. So what I am getting here is that my V value is 25 millivolt ln 11. This is my V value is. From here I will get the value of V. I need to bring the calculator. So just a second. So by the calculation, the V value I am getting is 0.06 volt. So this is the value of V I am getting. So now how I can replace my circuit? So this particular circuit, copy and paste. So here there was 10 microampere current which I am directly showing. 10 microampere current. Okay. This is virtually shorted, which I already know, so no need to show it. Here there is 10 microampere current. Now this diode will be replaced with the voltage of 0.06 volt. 0.06 volt. P side to N side. The voltage V. This is the voltage V. This is the voltage V. The diode was given. This diode was given. And they have considered this as voltage V. Now if this is the voltage V, then the current equation is this. This is the current equation. What is the current equation? I naught e to the power V upon Vt minus 1. This is given from their side, right? So this is what they have given. So We calculated the V voltage. The V voltage we are getting is 0.06 volt. And what is the current flowing here? The current we already know. That is 10 microampere. Right? The 10 microampere. Now this node is already at 0. Your target is to find V0 value. Your target is to find V0 value. So this 10 microampere current is flowing through 4 kilo ohm as well. So what will be the voltage drop across 4 kilo ohm? 10 micro. That means 10 to the power minus 5 into 4 kilo. 4 into 10 to the power 3. So that would be 4 into 10 to the power minus 2. It would be 0.04. Say yes or no. The drop will be 0.04. Since the current is flowing from right to left, then this will be the voltage drop. So this voltage drop will be 0.04. Let's just write 0.06 somewhere here. So this voltage drop will be 0.04 volt. So this was 0, the diode was turning on and it was becoming a battery of 0.06. Now 10 microampere current is flowing through 4 kilo ohm resistance. So 10 micro into 4 kilo ohm. 10 to the power minus 5 into 4 into 10 to the power 3. So 4 into 10 to the power minus 2, that would be 0.04. So 0.04 voltage drop is there. So if this node is 0, this node will be 0.06, this node will be, V node will be 0.06 plus 0.04. Right? So what will be your V node? V node will be 0 plus 0.06 plus 0.04. Right? So your V0 will be 0.1 volt. Say yes or no. This is your final answer. Did you understand this particular problem? Here in this problem, I did not replace the diode with the short circuit path or with the battery of 0.7 volt or with the battery of V gamma. Here the current equation was given. So I had to consider the ideal characteristics. So from there, I got to know the value of V. Then I got to know the current that is flowing is 10 microampere. So from there I could get the value of V. Then I replaced the diode with that particular voltage. Then I got to know that from the resistance as well 10 microampere current is flowing. So with the 10 microampere current we'll have a, now this 4 kilo ohm will have a voltage drop of 0.04 volt. So now your V0 voltage will be 0.1 volt. That's it. Well and good. Let's move towards the next question. So I should not remove that 10 microampere current. Next question will be very interesting. So put your whole concentration here, then only you will be able to understand. 5 millivolt voltage source is there, 5 millivolt voltage source is there, and the diode is there, same circuitry is there, everything is same. Now what do you think what will happen? Let's just assume the diode is giving us a particular voltage. Let's just assume the diode is giving us a particular voltage. This is what we are assuming. It is on or off, I don't know. It is giving me some particular voltage. Okay, the diode is giving me some particular voltage. So there is a negative feedback in node. If diode is giving me some particular voltage, let's just assume it is giving me a negative voltage. It is giving me a negative voltage or something, 0.1 micro. Still the diode is considered to be on only, no? Not the diode. Since it is giving me a particular voltage, that means certainly there is a negative feedback, right? So yes or no? If I replace this diode with a battery, the polarity I don't know, don't know nothing. I just know that this diode can be replaced with the battery. If I can replace it with the battery, then certainly there will be a negative feedback, right? So considering that diode is giving me a particular voltage, I am considering that there is a negative feedback involved. If there is a negative feedback involved, then this node will be 0 volt. What will be the current here? So what is the first assumption that I have made? Current, try writing the current by your own. Here I am writing the assumption. Assuming diode is giving me some finite voltage. Some finite voltage. So if it is giving me finite voltage, negative feedback is present. Negative feedback is present. That means virtual short is valid. Virtual short is valid. Right? So what is the current that is flowing? The current that is flowing is 5 milli by 100k. So 5 milli, 5 into 10 to the power minus 3 divided by 100k. 100k is 10 to the power 5. So 5 into 10 to the power minus 8. So you can write 50 nano. So the current that is flowing is 50 nano ampere. So the current that is flowing is 50 nano ampere. Now the same current will be going through this 50 nano ampere. Now what you will think? What you people will think? That sir, the current is flowing from N to P and diode is off. and if the diode is off, you will replace it with open circuit. Wrong. Why is it so? Diode is off. Nah, diode is in reverse bias. You cannot say diode is off. You could say diode is off if you were studying this characteristics. Like the light chili क्या हुआ पता नहीं current सा आया है यहाँ पे. Yeah. So if you were studying this characteristic, then you would have said the diode is off. So here it would give me 0 voltage drop. It would give me basically nothing. Here I should not make it like that. Yeah. So if you were studying this model, then you could have said that, sir, here the diode will be off. You can replace that diode to be open circuited. But the model is ideal. What is the graph of ideal model? This is your ID, not ID. Here it is shown by I. So I will write I versus V. I, and this is V. What is I? What is V? Let's draw the diode. This is the diode. This is your V. This is what they have shown, and this is your I. So if V voltage is positive, then it will go something like this. Right? And if V is negative, then it goes like this. Say yes or no. Now for the complete curve, they have given only one relation, that is I naught e to the power V upon Vt minus 1. E to the power V upon Vt minus 1. So what you need to consider? No matter how much current is flowing there, this equation will be always considered. What was your saturation current? Saturation current was 1 microampere. I naught value 1 microampere. This current is 1 microampere. This current is 1 microampere. Right? Now what is the current you got? What is the current that is flowing into the diode? The current that is flowing into the diode is, for now, that is 50 nanoampere. So where will be 50 nanoampere? If this is 1 microampere, 50 nanoampere will be somewhere here, right? This will be 50 nanoampere. And if this is 50 nanoampere, so with respect to this, what is the voltage drop you are getting? This is the voltage drop you are getting. Say yes or no. The current is negative, but certainly the diode can give you some voltage drop. The current is negative, but still diode can give you some voltage drop, because this is the characteristic. This is 1 microampere. So the current is 50 nanoampere. Current is 50 nanoampere. So with respect to that current, there will be some voltage drop. Right? Now that voltage drop we need to find. So the current equation is given this. I know the value of I naught, that is 1 micro. So 1 into 10 to the power 6 I am writing. E to the power V, I don't know, Vt 25 millivolt minus 1 is equals to I. So tell me, what will be the value of I? I is 5 into 10 to the power minus 8, right? 5 into 10 to the power minus 8. Now here I will write plus or minus. Plus or minus. The current I they have given in this direction. This is the equation. This equation is there for this particular configuration. So the current I is given like this. But the current that is flowing is 50 nanoampere in this direction. So the value of I is minus 50 nanoampere. Say yes or no. As per the given device, forget about diode. They have given a device. Just they have given a device. For that current equation in this direction they have given. But the current is flowing like this in 50 nanoampere in the opposite direction. So the value of I that you are getting is minus 50 nanoampere. Right? So here you have to put minus sign, because it is flowing in the opposite direction. Say yes or no. Is this concept clear or not? If it is not clear, take your time. It will be clear to you. Take your time. Everything is crystal clear? Well and good? Okay. So what you are getting? Minus 5 into 10 to the power minus 2. So it will be minus 0.05 e to the power V upon 25 millivolt minus 1. So e to the power V upon 25 millivolt This 1 will come here, so it will be 0.95. So the value of V will get is ln 0.95 ln into 25 millivolt into 25 millivolt, right? 0.5 ln into 25 millivolt. This I am getting is minus 1.28 millivolt. So the value of V you are getting is minus 1.28 millivolt. Yeah, so value of V you are getting is minus 1.28 millivolt. Okay, so there was a bit of interruption in between the video because there is some electricity issue. So this is the value of V you are getting, that is minus 1.28 millivolt. So your diode was there and this was your voltage V, right? This was your voltage. You would have replaced the diode by this battery and you would have written your voltage V. This is your voltage V, right? So you would have written your voltage V to be minus 1.28 millivolt. Say yes or no, like that. Now I can replace it with this battery, that is 1.28 millivolt. Did you understand this? I got V equals to minus 1.28 millivolt. This particular potential I got to know it is minus 1.28 millivolt. But for the given diode, for the given circuitry, the voltage V is taken from P to N. The voltage V is taken from P to N. So from P to N, my voltage is minus 1.28 millivolt. From P to N, my voltage is minus 1.28 millivolt. So from N to P, I am having plus 1.28 millivolt. So in this particular circuitry, now this particular circuitry, how it will be replaced? This particular circuitry, this will be replaced with the battery of 1.28 millivolt. 1.28 millivolt placed with the battery of 1.28 millivolt, and this 50 nanoampere current that is flowing through 100 kilo ohm will be flowing through this 4 kilo ohm as well. 15 nanoampere current. So how much voltage drop it will give me? So this voltage drop will be 50 nano, that means 5 into 10 to the power minus 8, 4 kilo. 4 kilo is 10 to the power 3. So 2 into 10 to the power minus 4, right? Is 2 into 10 to the power minus 4. So it would be 0.2 millivolt. So this voltage drop will be 0.2 millivolt. Voltage drop will be 0.2 millivolt. Say yes or no. Did you understand this particular question or not? Our current was flowing 50 nanoampere, that was flowing in the diode from N to P. You thought that the diode should be off. The diode should be replaced with open circuit, but no. The current equation was given for the ideal characteristics. The current was 50 nanoampere, that means it was running in this region. If it was running in this region, that means it would give me a drop of minus 1.28 millivolt. How did I get to know it? I took the current value to be minus 50 nanoampere because it was flowing in the opposite direction, not from P to N. It is flowing from N to P, so I had to take minus sign. Then I got to know that my potential is V equals to minus 1.28 millivolt. So my potential from P to N is minus 1.28 millivolt. From P to N it is minus 1.28 millivolt. So from N to P it is plus 1.28 millivolt. So it is plus 1.28 millivolt, and the current that is flowing in 4 kilo ohm is in this particular direction, that is 50 nanoampere, because the same current will flow in the 4 kilo ohm. So that would give me a drop of 0.2 millivolt. So what will be your output voltage now? Your output voltage would be 0 minus 1.28 millivolt minus 0.2 millivolt. So V naught value you are getting is minus 1.48 millivolts. So that would be nearly minus 1.5 millivolt. So this is what you are getting. You are expecting that your output will be minus V set. You are expecting that your output will be minus V set because the diode will be off. So this 5 millivolt will be coming here. If 5 millivolt is coming here, that is greater than V positive potential. So my output will be saturated to minus V set because there is no feedback present. But minus V set is not the final answer because you have connected the diode. Even in the reverse bias, it is giving you some voltage drop. And because of that, the diode is being replaced with the battery. And because of that, there is a virtual short concept valid. And because of virtual short concept, because of the battery and because of the current, we are getting a finite voltage that is minus 1.48 millivolt. Well and good. Understood? Crystal clear? Okay, so this was a very good question. Let's move towards the next question. You have to find the potential at node X. So how most of the people would have solved it. There is a negative feedback involved, so this will be 0. Now for finding Vx potential, what I can do, I can apply the concept of virtual short. Virtual concept I have already applied. I can apply the concept of nodal analysis here, or I can directly write that 4 into 3 plus 0 into 2 divided by 5 is equals to Vx. 4 into 3 plus 0 into 2 divided by 2 plus 3 is equals to Vx. So Vx is equals to 12 by 5. This answer is wrong. Why is it wrong? Let's check that out. Okay. The thing is, virtual concept is valid. If virtual concept is valid, what is your output? This is a negative feedback. Virtual concept is valid. If virtual concept is valid, what will be your output? Your output will be minus Rf by R minus 20 by R. R is 5 into the input voltage, that is 4. So that would be minus 16 volt, which is not even possible. So output will be saturated to minus 15 volt. Your output is saturated to minus 15 volt. If your output is saturated to minus 15 volt, what does that mean? That virtual short is not valid. Virtual short not valid. Now your virtual short is not even valid now. So this potential is not at 0. This potential is not at 0. Let's just call this potential as Vy. Vy potential is not at 0 now. Vy potential will be some finite voltage. What that voltage will be? Tell me. Directly can you tell? Or in the next page I will show you a diagram. So here there was 4 volt, 2 kilo ohm was there, 3 kilo ohm was there, 2 ohm was there, 3 ohm was there. This was your 4 volt. This was your Vx that we will show later on. And then there was 20 ohm. And the other end of 20 ohm is fixed. That is at minus 15. Right? And this is 20 ohm. So what will be the potential here? This potential Vy. The Vy potential will be, you can apply nodal analysis as well. Vy minus 4 divided by 5 plus Vy minus 15. Vy minus of 15. That means Vy plus 15 divided by 20 is equals to 0. From there also you can get, or what I can do. Vy would be equals to minus 15 into 5. Minus 15 into this resistance 5 plus 4 into 20 divided by 20 plus 5, 25. 75 plus 80. 75 plus 80. Okay, so that would be 5 by 25, 1 by 5. So Vy would be 0.2 volt. So this potential you are getting is 0.2 volt. It is not equals to 0. So if this is 0.2 volt, what will be the value of Vx? So Vx will be 0.2 into 2 plus 4 into 3 divided by 2 plus 3, 5. So 12 plus 0.4 divided by 5. 12 plus 0.4 divided by 5. So 12.4 by 5. 2.48 volt. So Vx potential is 2.48 volt. So this is the final answer. Previously what you were getting? You were getting 12 by 5. So 2.5 you were getting, no? 2.4 you were getting. So that is wrong. 2.48 is correct. Okay, 2.48 is correct. Well and good. So 2.48 volt is your final answer. Let's move towards the next question. Forward voltage drop for both of the diode is 0.7. You have to find the average value of V0. This average value of V0. This is what you need to find. So what you will do? Forward voltage drop is given. There is no ideal characteristic given. Nothing like that. So you have to consider 0.7 or open circuit. 0.7 or open circuit. If forward biased, then 0.7. If reverse biased, then open circuit. That's it. Well and good. So let's copy this circuit and do the analysis. So what we are going to do? We are not going to do anything. For 0 to t by 2. For 0 to t by 2. For 0 to t by 2. What is your V in? V in is equals to 1 volt, right? V in is equals to 1 volt. If this V in is equals to 1 volt and you apply open circuit test, directly I am going to apply. If you apply open circuit test and V in is equals to 1 volt, what will be your output? Your output will be minus Vset. If V in is equals to 1 volt, your output will be minus Vset. If your output is minus Vset, let's just call this node as V naught dash. If V in is equals to 1 volt, then V naught dash would be what? Plus Vset. Sorry, minus Vset, right? V in is equals to 1 volt, that means negative potential is higher, then V naught dash will be minus Vset. If it is minus Vset, then D1 is on and D2 is off. D1 on and D2 off. D1 is on and D2 is off. So how will you replace your circuit? This is off, so it will be open circuited. D2 is off, that will be gone. And now it will be replaced with the battery. With the battery of 0.7 volt. Right? This is replaced with the battery of 0.7 volt. Now there is a negative feedback involved. V in is equals to 1 volt, not minus 1 volt. So there is a negative feedback involved. This is the negative feedback is there. Some part of output is coming towards the input side. So there is a negative feedback involved. So this node will be equals to 0 only, since this is 0. And this node will be V naught plus 0.7, right? If this is V naught, then this node will be V naught plus 0.7. So I can apply nodal at 0. So I am applying nodal at 0. So that would be 0 minus V in divided by 1K plus 0 minus V naught minus 0.7 divided by 2K is equals to 0. 0 minus V in divided by 1K plus 0 minus V naught minus 0.7 divided by 2K is equals to 0. So minus of 2V in minus of V naught minus of 0.7 is equals to 0. 2V in is 1 volt only. V in is 1 volt, so 1 I can put here. So V naught is equals to minus 2.7 volt. So for 0 to T by 2, for 0 to T by 2, for 0 to T by 2, V naught is minus 2.7 volt. Now you will check for T by 2 to T. T by 2 to T. What is your V in? V in is minus 1 volt. If your V in is minus 1 volt, here your V in is minus 1 volt. If your V in is minus 1 volt, here if it is minus 1 volt, then it is lesser than the V positive potential, then V naught dash will be plus Vset. So if V in is minus 1 volt, your V naught dash will be plus Vset. Got to know this? Very, very easy concept. V naught dash will be plus Vset because V in is minus 1 volt. So V naught dash will be plus Vset. V naught dash will be plus Vset. And if it is plus Vset, that means D2 is on and D1 is off. D2 on, D1 off. D2 on and D1 off. So how will you replace your circuit? D1 is off. This is gone. This feedback path is gone. There is no use of that. And now this will be replaced with the battery. Minus plus. This will be replaced with the battery. Battery of 0.7. Battery of 0.7. And if there is a feedback involved, this is the feedback involved, right? There is a negative feedback involved, so the virtual short is valid. So what will be the V naught value? V naught value will be minus 0.7 volt. This is for 0 T by 2 to T. T by 2 to T, which is minus 0.7 volt. So how you will draw the graph of V naught? So first it is minus 2.7, then 0.7, sorry, plus 0.7, sorry, 0.7, 0 plus 0.7, it will be plus 0.7. So minus 2.7 and then plus 2.7, minus 2.7 plus 2.7. First you are getting minus 2.7 Then for next cycle you will get 0.7, then you will get minus 2.7, then you will get plus 0.7, and so on, right? This is your t by 2, this is your t, 3t by 2, and the same cycle is being repeated. First you were getting minus 2.7, then this was 0.7. So what will be your V naught average? Minus 2.7 into t by 2 plus 0.7 into t by 2 divided by time t. So if you solve it, this will be minus 1 volt. Your V naught average is minus 1 volt. That's it. Is there any calculation error? Let's check that out again. So let's check out what we did. First we saw that if V in is 1 volt, then your V naught dash would be simply plus V set, your diode D1 will be on. D1 will be on, it is replaced with the battery of 0.7. With the concept of nodal analysis, we got to know your V naught is minus 2.7 volts. So for then next T by 2 to T, where V in is minus 1 volt, then your diode D2 was on. The upper diode was on. If the upper diode was on, then it was replaced with the battery of 0.7. So simply your V naught was plus 0.7. So your V naught average is becoming minus 2.7 into T by 2 plus 0.7 into T by 2, minus 1.35 plus 0.35. So it would be minus 1 volt only. Well and good. Very easy. Let's move towards the next question. You have to find the output voltage. So this is a Zener diode, Zener, that has a breakdown voltage of 3.2 volt. The Zener has a breakdown voltage of 3.2 volt. So let's check out whether the Zener will go into breakdown or not. So what we will do? We will apply open circuit test. So applying open circuit test. So whether it will go into forward bias or reverse bias or into breakdown region. For Zener, we need to check 3 region: forward, reverse or breakdown. So applying open circuit test. Now I can replace. So if I apply open circuit test, this will be open circuited. This is open circuited, and V in is given is 1 volt. If V in is 1 volt, what will be your V naught? Because there is already negative feedback present. Even if the diode, even if this Zener is on, off, or it is in breakdown, no matter what, there is certainly feedback present. If there is feedback present, this node will be 0, then certainly this will be minus 10 volt. What did I mean to say is that I assumed the Zener is, I'm applying open circuit test, so I will keep Zener as open circuited. If I am keeping Zener as open circuited, my V naught is minus 10 volt. Why it is minus 10 volt? Because there is already a feedback present. There is no need of this for feedback. There is already feedback present, so V naught will be minus 10 volt. If it is minus 10 volt, then this node is at minus 10 volt and this node will be at 0, because this will not drive any current. This 10 kilo ohm resistance will not drive any current. So this 0 will be traveling here. So N side, this is the N side and this is the P side. So this is your Zener. This is your Zener. At one side you are having minus 10, the other side you are having 0. What does that mean? It goes into breakdown, and if it goes into breakdown, what you will do? You will replace it with the battery of its Zener voltage, that is 3.2 volt. The Zener goes into breakdown. This is what you understood here, right? So we can make the next circuit now. What did we do? We apply open circuit test. Arey yaar. We applied open circuit test. When we applied the open circuit test, we got to know that the voltage, the reverse voltage Zener is having is 10 volt in the reverse bias. But if it was having 3.2 volt, then only it would go into breakdown. So in 10 volt, it will certainly go into breakdown. So it is going into breakdown. So now this Zener can be replaced with the battery of 3.2 volt. This Zener can be replaced with the battery of 3.2 volt. 3.2 volt, right? And if Zener is 3.2 volt, what will be this potential? This potential will be V0 plus 3.2 volt, right? So what will be your output voltage? There is certainly negative feedback involved, so this node will be 0. So I can write 0 minus 1 by 1k, nodal I am applying, plus 0 minus V0 by 10k, plus 0 minus V0 plus 3.2 divided by 10k is equals to 0. Minus 10 minus V0 minus V0 minus 3.2 is equals to 0. 2 V0 is equals to minus 13.2. So V0 will be equals to 13.2 divided by 2. 2 6 12, 2 6 12, minus 6.6 volt. V0 will be minus 6.6 volt. That's it, right? What did I do? I just applied the nodal analysis. So let me check if the calculation is correct or not. 0 minus V0, 0 minus 3.2k divided by 10k, all are negative, minus 2 V0 minus 14.2 minus 13.2, so minus 6.6. Yeah, so answer is minus 6.6 volt. Very easy question. Let's move towards the next question. So let's solve the final question. It looks like a big circuitry, but it is very easy. You don't need to worry about it. You need to find the final V0 voltage. The diode current expression is given. The voltage drop across the diode is given, and I0 value is given, R value is given, V1 value, V2 value is given. Finally, you need to find the V0 voltage. So this configuration is there, this configuration is there, then finally this and this. All the configurations you know. You have already studied all the configuration. I just cascaded all the configuration and made this question. That's it. What is this configuration? Do you remember? It is logarithmic amplifier. Even if you don't remember, it is fine, because in the you can analyze it as well. And here I am going to analyze it only. I am not going to write the final result. This is logarithmic amplifier. What is this? Differential amplifier. This you should remember. What is this? This is exponential amplifier. And what is this? Inverting amplifier. Right? So let's solve all the configuration one by one. So let's assume this output is V01, and this not here. I should not do it here. Let's move to the next page. So let's assume this output is V01. This output is V01 and this output is V02. So what will be the forward voltage drop here? The forward voltage drop VD value, that will be minus V01, and what will be the forward voltage drop here? That would be minus V02, because here there will be certainly negative feedback involved. Why there will be negative feedback involved? Because the current equation is ideal. The current equation that is given is ideal. Even if the diode is in reverse bias, it will not be replaced with open circuit. It will be replaced with a battery. We saw the particular question. In that question, what was happening? The diode was in reverse bias. Still, it was replaced with a battery of minus 1.28 millivolt. So similarly, in this case as well, you don't need to think whether the diode will be on or off. Certainly, there will be a negative feedback involved, because the diode is going to be, eventually it is going to be replaced with the battery. It could be minus 1.28, minus 1.38 millivolt or anything, but it will be a battery for sure. Well and good. So that's why certainly there will be a negative feedback involved. So this node will be 0, this node will be 0. If this node is V01, this node is V02. So what is the forward voltage drop across the diode? Forward voltage drop, that is minus V02. The VD value I am writing. VD value is minus V02. VD value is minus V02 and VD value here is minus V01. So what will be the current here? The current here would be V1 by R. And what would be the current here? That would be V2 by R. Right? And the same current will be flowing here as well. The same current will be flowing here as well. So what you can write now? This will be used later on, so forget about it. V1 by R is equals to I naught e to the power Vd. What is Vd? Vd is V01. E to the power Vd upon eta it. E to the power Vd is minus V01. Vd upon eta it. Well and good. So from here, what did you get to know? That your V01 is V01 is minus eta Vt ln V1 by I naught R. Say yes or no. And similarly, what will be your V02? V02 will be minus eta Vt ln V2 by I naught R. Because similar circuit is there for V02. What you will write for V02? That V2 by R. Why I am writing I naught by I naught R? It is eta Vt. Sorry. No, it is I naught R only. Sorry. Let me check again. Yeah. So for V2, what it will be? For V2, it will be. How will you write the current equation? Current equation is V2 by R. V2 by R is equals to I naught e to the power Vd. What is Vd? Vd is minus V02 upon eta Vt. Then this I naught will go here. This will be V2 by I naught R. Then exponential will go here. It will become ln V2 by I naught R. Then this negative eta Vt will come here. Right? So minus neta Vt ln V2 by I naught R. This is V02 and this is V01. Now this is equation 1. This is equation 2, we can say. Now this V01 and V02 is fed to this circuitry, right? So this is what I have made here. V01 and V02 is fed to this circuitry. What is this? Differential amplifier. Do you remember the answer for this? Yes, I directly remember the answer. But for the condition that this to this ratio and this to this ratio is same. Yeah, it is same. R by R is equals to R by R. So the ratio is same. So that would be, आज तो करंट लगेगा भाई. So that ratio would be RF by R, V positive potential V02 minus V negative V01. V02 minus V01. So what is V02? V02 is minus eta Vt ln V2 by I naught R minus V01. So minus negative sign will come, minus eta Vt ln V1 by I naught R. Now eta Vt will be coming common here. Ln V1 by I naught R. This I am writing ln V1 by I naught R minus ln V2 by I naught R. So this is ln A minus ln B. Ln A minus ln B. What it will be? Ln A by B. So eta Vt ln V1 by I naught R into ln A by B. So this I can write reciprocal. Basically V03 I am getting is eta Vt ln V1 by V2. V03 I am getting is eta Vt ln V1 by V2. This is equation 3, right? This is your, this V03 is being fed to this stage. This is the V03 that we are taking. This is fed to this stage and we are assuming that finally we are going to get V04. So this will be your V04. So V03 is fed to this stage. This is your V03. So here the forward voltage drop is V03, right? And let's just assume the current here is ID. The same current ID will be flowing through this resistance. So what will be your V04? V04 is minus ID into R. Say yes or no. V04 will be, this node will be 0 only. So it will be minus ID into R. So what will be the equation of ID? ID will be minus I naught exponential Vd. What is Vd for this? Vd for this diode, that is V03. V03 upon eta Vt. Say yes or no, right? This is your V04. Better I should make on this side. This is your V04. So what you can write? V04 is equals to minus I naught. Okay, wait a minute. Minus I naught into R as well. R also will come, no? This is the expression of ID only. Minus I naught exponential e to the power V03 upon eta Vt into R. So minus I naught into R exponential. What is the value of V03? V03 is eta Vt ln V1 by V2 divided by eta Vt. V04 would be minus I naught R, eta Vt and eta Vt is getting cancelled. Now you are having exponential and ln V1 by V2, right? Exponential and ln will also get cancelled, so what you will get? Minus I naught R exponential and ln is getting cancelled, so minus I naught R V1 by V2. This is your V naught 4. This is your V naught 4. And directly you can see, if this is your V naught 4, from here only you can see what will be your V naught. V naught will directly be, because this is a inverting amplifier, so V naught will be minus of V naught 4. So V naught will be minus of V naught 4. So your final V naught is minus of V naught 4, and that would be I naught into R into V1 by V2. This is your final answer, I naught into R V1 by V2. Now the values are given. What is the value of I naught into R? I naught into R is 1. I naught is 1 micro, R is 1 mega. So I naught is 1 micro, I naught is 1 micro, and R is 1 mega. And what you are getting? V1 by V2. So what is the value of V1? V1 is 2 milli and V2 is 4 milli. 2 milli divided by 4 milli. Final answer would be V naught is 0.5, not volt, volt per volt. V naught is 0.5 volt per volt. It is volt per volt or something else? No, it is volt only. Sorry. It is volt only, because I naught R will give you voltage. Look, this will give you voltage, no? I naught R, voltage into volt per volt. So volt and volt getting cancelled, only volt you are getting. So V naught value will be 0.5 volt. This is your final answer. V naught is 0.5 volt. Well and good. Easy. So this was working as a potential divider. Divider circuit it was. You had two inputs. You had V1 and V2. You passed V1, V2 through this circuitry. Through this big circuitry, you passed V1 and V2, and finally what did you get? I naught into R, V1 by V2. So I naught into R value you have adjusted to 1 only. So finally you were getting V1 by V2 only. So this was a divider circuit. You applied two input V1 and V2 to this particular circuitry, and in the final answer you analyzed the complete circuitry. It was very easy to analyze. We analyzed the stage one by one, and in the final answer we got that your V naught is I naught into R V1 by V2. So this was your V1 by V2 that you got 0.5 volt. Well and good, very easy. So we are done with this assignment. Now in the next video we are going to study about filters. Okay, so we will certainly study about filters, and then we will solve one more assignment. So after video assignment, because in the op-amp part the questions are important, problem solving is important. Okay then, thank you.